Check, check, check one. Hope online students can hear me clearly. Online students, please confirm if they can hear me clearly. Check, check. Jangan lupa clear. Oh, nih. Okay. Minaga. Yep. Toots. Minaga. Uh, okay. So let's start the class. Hope everyone can hear me clearly. Uh, yeah. So I think everyone and you can find the tunes on the WhatsApp group. And the Zoom chat, but I'll upload everything in the Zoom chat WhatsApp group again. And I'll give you a contact number for online students, especially YouTube Live students, if they need any assistance related to the online class. Yeah. And sorry for doing the class on a holiday, I think. So usually, I don't take holidays. So, you don't need holidays. Otherwise, you're going to do something useless today, right? That's why. Okay. Okay, so last week we discussed about units. So we have to like continue with the units. And I said that I'll repeat things related to units, the properties of units. So let's continue with units. Let's first learn the properties of units again. I'll just revise the properties of units again. Then let's continue with these areas. And at the same time, as we always do, I'll be doing one or two mechanics question. Okay, you will find it really useful when we start mechanics, because then you always, I mean, you already have the common sense related to mechanics when I'm starting mechanics. That's why I do at least 2 3 mechanics questions every week. So today also let's do units and measurements. Let's continue with units, then let's continue to dimensions, then let's continue with let's start with units, then move into dimensions, then let's do some mechanics questions. That is the basic plan for today. Uh, and hope I mean, there are a lot of online submissions for the paper. So please do write the paper if possible. Um, at the beginning, some students may find it difficult. Some students may find it really easy. There's a huge, I mean, spectrum of students who at with different knowledge levels, different level of understanding, with different level of thinking speed. Okay, but at the end of the day, if you keep doing the paper, then after like 1 or 2 or 3 months, maybe the first papers you will get only 1 or 2 marks at the beginning. Okay, so at the same time there may be students who are getting 14 out of 15. Okay, so that's how it is. Okay, that's how it is in A levels. So you may start with 1 or 2 marks, but if you keep writing the paper, then you will move into 14 15 marks like that. Okay, that is the basic requirement. Keep writing the paper, not getting very high marks. That is not the requirement. Keep writing the paper is the basic requirement. Okay, that's how we improve. Okay, so I'll give you some questions to revise things related to units, and then let's continue. uh, I just have to plan a question. Okay, T is measured in, T is time, that means measured in seconds. T is time, that means it's measured in seconds. Find the units of A, B, K, and L. A, B, then K, K, and L. Quickly try to get these values. This is 5, okay? This is 5. A over K, this is 5. Number 5. Okay. So just try to get the answers for these questions. Write these questions on your book and try to get the answers for these questions. And at the same time, if there's any new students or if there are students who need some revision, I'll repeat the properties of units. Okay. So if you are okay with the theory points, then just continue the questions. Okay. Continue the questions. But if you need a small revision, I'll revise the points related to units. And I'll give another question. This is 1, 2. V is velocity. V is velocity. That means unit is meters per second. T is time measured in seconds. T is time measured in seconds. Uh, then capital T is temperature measured in kelvins. Capital T, temperature measured in Kelvin. I need you to find R. I need you to find the units of R, P, R, P. Yeah, units of R and P. Write down these two questions. Then I'll repeat the properties of units for others. Try these two questions. Find units of R and P. I hope it's possible. Yes. Quickly write this down. Quickly write these two questions on your book. Okay. So for others, I'll repeat the properties of units. So if we talk about units, uh, still writing anyone? Still writing? Yeah, quickly write this down. Quickly write down the question. Then try to get the answers. T is measured in seconds. This is 5. This is 5. T is measured in seconds. I need you to find the units of A, B, K, and L. Here, V is velocity measured in meters per second. T is measured in kelvins. Then here simple T is measured in seconds. I need you to find the units of R and P. R and P. So I'm going to put AC is at 19. Just let me know when it is too cold, okay? Okay. So let's start. What are the properties of units? You can't add units. You can't subtract units. Can you remember? You can't add or subtract units. That means 5 kilograms plus 2 kilograms. It's not like 7 kilograms. It's the same unit, 7 kilograms. You can't like add the units separately, okay? So 5 kilogram plus 2 kilograms, it's just 7 kilograms. It's not 7 kilogram or something like that. Clear? And at the same time, due to this result, you can't add or subtract things with different units. Can you remember? You can't add or subtract things with different units. That means you can't add 5 kilograms with 2 meters. Not going to happen. Clear? You can't add 5 kilograms with 2 meters, 2 kilograms with 3 kelvins. It's not going to happen. Clear? But when you divide or subtract, yes, sorry, when you divide or multiply, it's possible, right? You can multiply whatever the units you like. Y units can be multiplied. That means 2 Newton into 3 meters equals 6 Newton meters. So units can be multiplied, units can be divided, but you can't subtract or multiply units. Clear? Clear? Then what are the other properties that we learn? Um, Another property, for an equation to be correct, both sides of the equation, they must have the same unit. Clear? That means if you have an equation like P equals H rho G, this was the example that we used last week. If you have an equation called P equals H rho G, units in this side must be equal to the units of this side. Clear? For an equation to be correct, you must have the same units in both sides. Clear? Then what's next? Um, for a power, you can't have a unit. So 5 to the power 3 kilograms, it's meaningless. Meaningless. So you whatever you have here should be unitless. Clear? You can't have a unit here. Clear? Whatever you have here should be unitless. Clear? Then when we talk about log function, when we talk about log function, you can't put anything with a unit into a log function. Clear? That means log, here you can't put 3 meters. No, you can put only a number here. Clear? So you can't put anything with a unit into this log function. Clear? You can't put anything with a unit into this log function. Clear? Okay. So in a log function, you can't have anything with a unit. Can you remember? Then as a result of a log function, you never get anything with a unit. Clear? So the result of a log function, the value you get from the logbook can't have a unit. So the log function, it never provides a unit. Clear? So whatever the value you get, I mean, you find log 5, you get an answer using this. Okay? Whatever the answer you get out of this will not have any unit. Clear? Whatever the answer you get out of this won't have any unit. Clear? So log 5 is just a number. Answer of the log 5 is just a number. Then sine, cos, tan, trigonometric identities. Can you remember? Sine, cos, tan, trigonometric identities, they don't have units. That means sine anything. Sine anything can't have a unit. Why? Why? Sine anything can't have a unit. Why? What is the reason? I mean, sine, cos, tan means length divided by length, right? Sine, cos, tan means A, B, C. It's length divided by length. Sine theta means A over B. Cos theta means C over B. Tan theta means B over C. Clear? All sine, cos, tan values are length divided by length. Clear? So when you divide length by length, you won't get anything, right? When you divide length by length, you won't get anything out of that, right? So sine, cos, tan values can't have units. Clear? These are the fundamental identities that we learn related to units. Clear? Now I need you to use these things, okay, in a question. And at the end of the day, so if you have an equation like this, A equals B plus C over R plus T k to the power 3, anything like this, if you have something like this, unit of this quantity must be equal to unit of this quantity, must be equal to unit of this one, must be equal to unit of this one. Clear? Why? To add, you must have same units everywhere. Then after adding these quantities, you get the same unit. So you must have the same unit in this side also. Clear? So for in an equation like this, unit of this part must be equal to unit of this part equals to unit of this part equals to unit of this part. Clear? That is the idea. Okay. So back to the question. Try to get answers. Hope everyone got the mechanics tube, right? So if you finish a question quickly, try go to the mechanics tube and try to finish 1 or 2 questions. And today you will get the workbook. Okay. Today you will get the workbook for units and dimensions. So whenever you have time, especially in the class, okay, if you get the answer quickly, then you can continue the workbook. Okay. Today you will get the workbook for units and dimensions. And for online students also, you will get the workbook for now as a PDF. And we have provided you the Google form to get tudes delivered. So please, if you haven't filled the Google form, online students only, physical students will get the tudes from the institute. Online students fill that form so that we can deliver the tudes within the first week of this month. Okay, that is the plan. So by next week, I mean within this week, you will get your tudes. Okay. So if you haven't filled the Google form related to delivering the tudes, please inform us. Mali. Okay, දුන්නද? Yeah. Okay. So let's try to get the answers here. Attention. So this is measured in seconds. Okay. This is measured in seconds. So what is the idea? You can't put anything with a unit into a log function. Okay. You can't put anything with a unit into a log function. So if this is seconds, B must be in seconds, right? B must be in seconds. Why? Then seconds to seconds cancels out. Then you don't have a unit here. Clear? So if T is in seconds, B must be in seconds. Clear? So the unit of B is seconds. Clear? Then it's done. Since then result of a log function can't have a unit. Result of a log function can't have a unit. So this part don't have a unit. Clear? This part don't have a unit. Clear? Result of a log function can't have a unit. So this part, it doesn't have a unit, but B, it's in seconds. So here it's the same B. So the unit of this one is seconds. Clear? So this part is unitless. This one is S, seconds. So the unit of whole part, it's seconds into nothing. Clear? Seconds multiplied by nothing. That means still seconds, right? Still seconds. Clear? So the unit of this whole part is seconds. Clear? Then if this part is in seconds, okay? If this part is in seconds, this must be seconds, right? Why? For the equation to be correct, unit of this part must be equal to unit of this part must be equal to unit of this part. Clear? So this must be seconds. Clear? Since the unit of this whole part is seconds, this must be again seconds, right? Why? 5 seconds equals 5 seconds, but you can't tell 5 seconds equals 2 kilograms or 5 kilograms or anything like that. So you must have the same unit everywhere. Clear? Then this part, A over K. This is 5 to the power KL. So here, this part, when I consider this part, this is number 5, just a number. So number into any power, you won't get any unit, right? 5 is just a number. It's a numerical value, just a numerical value. Clear? So a numerical value to the power anything, you won't get a unit out of that, right? Clear? You won't get a unit out of that. I mean, if it is 2 meters squared, then it is 4 meters squared. See, there's a unit. Clear? But if it is 2 squared, it's just 4. Clear? It's just 4. So since 5 doesn't have a unit, you don't have a unit in this part. Clear? But here A is in seconds. Here A is in seconds. Okay. And what is the basic requirement? Unit of this part must be equal to units of this part must be equal to units of this part. Clear? So if this is in seconds, if this whole part is in seconds, this part must be in seconds. Clear? So here this part it's unitless. Clear? And this is seconds. So k must be unitless, right? K must be unitless. If k is unitless, then this whole part will be seconds, right? Why? This is unitless, this is seconds, then this is unitless, then this whole part is seconds, right? Clear? So k must be unitless, right? K must be unitless. Why? This is seconds, this whole part is seconds, and this whole part must be in seconds. So for this whole part to be in seconds, since there's no units here in this part must be in seconds. And if k is unitless, then seconds divided by nothing multiplied by nothing, you will get seconds, right? So this part must be unitless, right? Clear? This part must be unitless. So k is unitless. Then we return to this part. This is 5 to the power kl. 5 to the power kl. So a power can't have a unit. A power can't have a unit. Since k is unitless, see? Since k is unitless, L must be unitless for this whole part to be unitless. Clear? Since k is unitless, this for this whole part to be unitless, L must be unitless, right? Clear? That's how it works. Clear? Clear, everyone? So L must be unitless. Clear? Clear, everyone? So the idea is uh, A is seconds, B in seconds, K unitless, L unitless. Clear? Clear? I'm just writing it like this. I mean, I can take part by part, write it in a essay type and explain things that way. But I need you to, I mean, you must be able to analyze it like this. Okay. Why? As I explained, this is not physics. This is just common sense related to physics. Okay. I mean, whenever you are doing some calculations, whenever you are doing a huge question related to mechanics or something else, uh, I mean, without any effort, you must be able to keep writing the units. Okay. That's the ability that we expect. Okay. This is not physics. Okay. So, I mean, you must be able to just look through this and analyze it this way. Okay. That is the uh, skill that we expect. Try this one now. Try this one. Oh, I mean, I'll explain it. I'll give you like 1 or 2 minutes to write this down. Then I'll explain this one. And if you have time, you can start doing the mechanics tute and also the workbook. Okay, let's try this one. Let's try this one. Okay, so here V is in meters per second. Okay, V is in meters per second. Then A is in, it's like this. this whole part can't have a unit, clear? Because it's a power, right? It's a power. This whole part can't have a unit, clear? So AV is unitless. AV is unitless. That means unit of A into unit of V. That means meters per second. Unit of A into meters per second must be unitless, clear? When you multiply this unit and this unit, it must be unitless, clear? So the unit of A is 1 over meters per second. That means per meter seconds, clear? Per second, here it's seconds, meter, here it's per meter, clear? So this is the unit of A, unit of A. So this is the unit of A, and it's the same unit here. Okay. Now what else? Here. Here. T is measured in kelvins. This is a power. So power must be unitless. So B must be 1 over kelvins, right? B must be 1 over kelvins. Clear? If B is 1 over kelvins and T is kelvins, then this part is unitless, right? If B is 1 over Kelvin, T is Kelvin, then 1 over Kelvin to Kelvin cancels out, then it's unitless. Clear? So B must be 1 over Kelvin. Clear? It must be 1 over Kelvin. Clear? Now, that means per Kelvin. B is per Kelvin. Okay. Now we have A, unit of A is this, unit of B is -1. Clear? Unit of A is this, unit of B is K to the power -1. Clear? Now what? Now this is the analysis. You understood up to this point, right? Why? Sorry? There's a sign. Yes. Yeah, this whole part is unitless, definitely. This whole part is unitless, and this is a power itself. So this must be unitless, right? Clear? Okay. I'll explain the whole question, then I'll repeat again, then you will understand. So this power must be unitless. It's clear, right? This power must be unitless. It's clear, right? Okay. Then this is A. We already know the unit of A. Clear? B. We already know the unit of B. Sorry? This one. Okay. This is a power. 0.2 to the power something. A power must be unitless. So 0.2, here it must be a unitless quantity. So T is measured in kelvins, then B must be measured in 1 over kelvins, right? If B is measured in 1 over kelvins, if T is kelvins, then units cancels out, right? Clear? A power must be unitless. Forget the sign. This is a power, right? I mean, no matter, it may be in a sign, in a log, wherever it is, a power must be unitless. This is a power of something, right? A power must be unitless. Clear? Even when it is in a sign, right? Okay. So T is kelvins, B is 1 over kelvins. Then they cancels out, right? Clear? That is the idea. Okay. Uh, and basically the point of giving the workbook is, I mean, especially for English medium students, there's a huge issue related to these resources. Okay. I mean, the books now there are translations, Sir's books are translated, Rosa Sir's books are translated, but I mean, they don't have this exact feeling of the book. I mean, of the writer. So anyways, what I'm trying is I'm trying to translate all the resources into English medium. At the same time, we are providing the Sinhala medium workbook too. So that, I mean, what I need to guarantee from my side is, if you are doing all the resources provided by me, not the basic maths book, okay, it's a different story. Okay, it's for your brain. not for A levels. It's a different story, but except that if you just complete all the resources, that's more than enough. That's I mean that I can guarantee. Okay, so you will get workbooks for each lesson. Okay, so the basic idea is if you just finish the book and do everything provided in the class itself, then I can guarantee that it's more than enough. Okay, that's the plan. Okay, so is this clear up to this point? Yeah. So now 2 is just a numerical value. Okay, 2 is just a numerical value. Clear? So power of 2 is again just a numerical value, right? 2 is unitless, it's just a number. So power of 2 is again just a number, right? Clear? So this whole part can't have a unit, right? This whole part can't have a unit. Why? This is just a number. Power of a number is unitless, right? Clear? So this whole part is unitless. Clear? Clear? Then if this is unitless, this is the unit of this part is this one and this. What is the unit of this whole part? Let's take it here. What is the unit of this whole part? This is unitless, so there's you have nothing here. Here unit is unit of A seconds. Here unit of B per Kelvin per Kelvin. Clear? Then what do you get when you solve this? This is unitless. Meter second per Kelvin. Here it's Kelvin. Clear? Clear? This is the unit of this whole part. Clear? Is that clear? Unit of A divided by unit of B multiplied by unit of this part, which is nothing. Clear? So now if the unit of this part is this one, this must be equal to the unit of this part and this must be equal to the unit of this part, right? Why? L equals m plus n. You must have the same equation in each quantity, right? Okay, for add these two, or it's a subtraction. So to subtract these two, you must have the same unit here and here. Then you must have the same unit here. Clear? So the unit of this part is must be equal to the unit of this part, which is this. Clear? Then unit of R we don't know. Unit of T, it's in seconds. Unit of R we don't know. Unit of T, it's in seconds. Must be equal to the unit of this whole part, which is this value. Clear? Per meter second Kelvin. Clear? Then I cross multiply, I take S here, then unit of R equals, per meter, here I take S here, then it becomes S squared Kelvin. Clear? Per meter S squared Kelvin. Clear? So the unit of R is this one. Clear? And unit of this whole part must be equal to the unit of this part. Clear? For you to subtract them. Then this sign value can't have a unit, right? Why? We know result of a sign value can't have a unit, right? Result of a sign value can't have a unit. Clear? So the unit of this whole part is unit of P into nothing. Clear? So the unit of this whole part is unit of P into nothing. Clear? Multiplied by nothing. And it must be equal to unit of this whole part must be equal to the unit of this part, which is this one. Clear? That means per meter SK. This is unit of P. Clear? So unit of P, unit of R. Clear? Clear? Got the idea? inform me if you need me to repeat this again, or else you can write this down. No, like you can write these units whatever the order you like, okay? There are some conventions related to that, but we can ignore them. You can write these units in whatever the order you like. Okay, so let's continue with the new part. I will write this down quickly. And whenever you have time, try to finish the workbook, okay? We'll provide the workbook for online students too. Whenever you have time, try to finish the workbook. Only. All the recordings are available in the group, but anyways, I'll provide all the recordings again in the group, okay? So that you can refer to all the recordings. Uh, so let's continue again. Uh, new concept, which you may already know, dimensions, okay? What is this idea? Dimensions, so we can call it dimensions and dimensional analysis. What is this idea? It's like this. So when we talk about a physical quantity, usually these dimensions we should teach it before units, okay? But which I usually choose to teach units before dimensions. Why? You already have a common sense related to units, right? Okay, you already have a common sense related to units, so it's easy to teach units. Then using units, it's easy to teach dimensions. But in the actual case, dimensions should come first, okay? And especially if there are Sinhala medium students, okay? Sinhala medium lamai innawa nan, and if there are students who prefer more Sinhala explanations, it's better to join the Sunday class, okay? We have a separate Sinhala and English class, a mixed class, Sunday evening 2 to 5:30, as I remember. Sorry. So this is the idea. Uh, so when you take a length, you can write this length, okay? You can write this length using meters, centimeters, kilometers, light years, yards. There's I mean, you have like thousands of units that you can measure length, right? Okay. But at the end of the day, it's a length, right? At the end of the day, it's a length. So we need, I mean, we can forget all the units, and it's better to know how physical quantities are connected with fundamental physical quantities. Can you remember the fundamental physical quantities? Okay. So if you have missed the previous sessions, if you have missed one first, second sessions, I'll provide all the recordings again in the WhatsApp group. Okay. And if you are not in the WhatsApp group, I'll provide you a number today. You can contact that number and join the WhatsApp group. So uh, the idea is, at the end of the day, whatever the unit you have here, the fundamental physical quantity is a length, right? Here the fundamental physical quantity is length. So we needed a method, okay, to forget all the units and give symbols to fundamental physical quantities, so that when we analyze another physical quantity, we know how it is linked to other physical quantities. That means some people may use light years, some people may use yards, some people may use foot, some people may use meters, some people may use centimeters. Okay, there are different conventions, but if we can have a common symbol called L for length, this is a common symbol for length. If we can have a common symbol related to mass as capital M, if we can have a common symbol related to time as capital T, if someone mentions, think that you don't know what is velocity. You have no idea what is velocity, okay? But someone tells that there's a physical quantity, and this this symbol of that physical quantity, there's a physical quantity called velocity, and this symbol which is related to that velocity is LT minus 1, then you know that this is a physical, I mean, there may be people who use different units, but everyone will know that this is L over T, that means length divided by time. See, when we have a common representation for the basic physical quantities or fundamental physical quantities like this, clear? When we have a common representation for fundamental physical quantities like this, everyone, all the people who use different units will have a common understanding about the ingredients of other physical quantities, clear? So if someone tells that the symbol of velocity is LT minus 1, then everyone knows this is length divided by time. See, so if we can have a representation like this, it's easy to understand all the physical quantities, clear? It's easy to understand all the physical quantities. We can have a common understanding about how this physical quantity is related to other physical quantities, clear? Fundamental physical quantities. So this we call the dimensions, clear? Dimensions and dimensional analysis, clear? That means we give a common name to fundamental physical quantities. Length, use the symbol L. So this is the dimension of length. For M, use this symbol, capital M. For T, use this symbol. Clear? Then after this, you have for temperature, you can use theta. For electric current, you can have A. So for all the fundamental physical quantities, you can have different symbols. But in our syllabus, we mainly analyze this connection, okay? We mainly analyze relationships between L, M, and T. Clear? So when you have a nice and common representation like this called dimensions, now you can forget the units, and everyone will understand how other physical quantities are related to fundamental physical quantities. Clear? That is the idea. So this is how we represent dimensions. That means this is these brackets it represents that I need the dimensions of velocity. Clear? So the square brackets, it tells that I need the dimensions of velocity. Clear? So if someone writes something like this, then you know it's LT minus 1. Clear? Ah. So quickly find dimensions of P, dimensions of work, dimensions of work, dimensions of work, dimensions of P, pressure, work, pressure, dimensions of force. First, I mean, let's first try find dimensions of force, find F, then find work, then find pressure. Try to find these things using these symbols. P is pressure, pressure. W work, work. W is work, W is work. F is force, F is force. W is work, P is pressure. Clear? F is force, W is work, P is pressure. So for to find the dimensions of force, what can I use? F equals ma. I can use F equals ma. Clear? So this is how we write it. Dimensions of F equals dimensions of ma. Then this is equal to dimensions of m into dimensions of a. Clear? Clear? Then m, its mass, that means capital M. Clear? Acceleration, I mean for you guys, it's easy to understand the unit, then bring dimensions here. Okay? Otherwise, it's the other way around, right? Dimensions comes first. Then we first teach there are basic physical quantities. This is the correct order to teach science, okay? You have basic physical quantities, then we give symbols to basic physical quantities, okay? Then we give symbols to basic physical quantities. Then we give teach you that there's something called velocity. Then we give the dimensional representation of velocity. Then we tell that to measure these dimensions, we use measurements. Then we tell that there are units for measurements. Then we learn measurements, okay? Then we learn units. That's the correct order. But since already you know the units, since you don't know the dimensions, then it's easy to go in this path, okay? I mean, that's how the physics works, okay? If you go for like maybe Colombo Physical or somewhere like that, I mean, this time I have a lot of students. I mean, for now, around 4 or 5 students said that district top 50 or 100. Yeah, district top 50 students, around 4 students said that they are going to skip engineering this time and going to learn physics. No, 3 of them are going to learn physics and other chemistry. So continue with chemistry or physics. So if you go somewhere like that, then you will learn like, I mean, it's very different. In maths, in maths you never think about why 1 plus 2 is 3, right? But in maths, Colombo physical mathematics, or even in engineering in the first semester, in the maths paper, you can't write sometimes 1 plus 1 is 2. You have to prove that why 1 plus 1 is 2. Okay, why 1 plus 1 is 2. You have never thought about this, right? Okay, why 1 plus 1 is 2. So sometimes to prove that 1 plus 0 is 1, to prove that you have to write for 3 or 4 pages. Okay, okay, you have to prove it for 3 or 4 pages why 1 plus 0 is still 1. Okay, even in physics, why this unit is this one. There's a lot of meaning and there's a lot of science behind that which we completely neglect, and we start from middle. Okay, so M, it's capital M, right? Mass. Then acceleration, it's easy for you to understand using the unit. Why? You already know the unit of acceleration. It's meters per second squared. That means meters over second squared. Meters means length. This is the dimension of length, right? Meters means length. Clear? This is the dimension of length. What is the dimension of seconds? Time, right? It's time. That means capital T. Capital T. Clear? So since you know the unit, it's easy for you to write the unit, write the dimensions using the knowledge of units. Okay, so meters per second square. Meters means length, seconds means t. Clear? Why? Seconds means time, symbol of time is capital T. Meters means length, symbol of length is capital L. Clear? So you can write here L t squared, then you get M L t minus 2. M L t minus 2. Okay. Then next one. Work. Work. What is work? Force into distance or force into displacement. You already know that equation, right? Work is force into distance, right? Clear? Work equals force into distance. Can you remember? Okay. So dimensions of work equals, you can write like this. You can write like this. Then you can separate them. Dimensions of Fs equals dimensions of F and dimensions of S. What is the dimension of F? It's this one, right? Clear? ML T minus 2. Clear? ML T minus 2. Clear? Then what about S? S is a distance, right? That means it's a length, right? S is distance. Distance is a length. What is the symbol for length? Capital L. Capital L. Clear? Clear? So you have ml squared t minus 2. So this is just a symbolic representation of physical quantities, okay? How the physical quantities are connected with fundamental physical quantities. Clear? This is how work is a derived physical quantities. Vyutpanna bhautika rashiya. Clear? Work is a derived physical quantity. Now we know how this is related to the related to the fundamental physical quantities. Clear? That is the idea of learning dimensions. Clear? Clear, everyone? Yeah. Write this down. Then let's try to find the dimensions of pressure. Others, I mean, can start exercise 3. Try questions in exercise 3. In your main note, theory note, questions in exercise 3. If someone can't find the tute, or if someone can't find the note or the workbook or anything like that, check the group. Everything is available in the group, and it's again available in the Zoom chat. But if you can't find, just drop a message at the Zoom chat or message this number. You can message this number and get all the details. And if you need to join the group, contact this number. And at the same time, if you need tutors, especially YouTube live students, contact this number. Just drop a message to this number. Not 70 402 not 70 402 9701. Not 70 402 9701. Then pressure, force of area, pressure, force of area, clear? Pressure equals force of area. Uh, then dimensions of pressure equals dimensions of force over area. Then this is equal to dimensions of force over dimensions of area. This is equal to dimensions of force over dimensions of area. Then force means we already know. Force means dimensions of force is ml t minus 2. ml t minus 2. We already know force. It's ml t minus 2. Then area, it's L squared. Clear? Area, it's L squared. Clear? Area means length into length, right? Actually, length into width. Clear? So for area, it's L squared. Clear? Thank you. Okay. Area, it's L squared. So L to L cancels out. Then I get M L minus 1 M L minus 1 T minus 2. M L minus 1 T minus 2. Okay. So next, uh, anyone writing this? Okay, quickly finish. And whenever you have time, try to finish the workbook. But uh, I think still you can't do much questions from the workbook. By next week, you will be able to like finish maybe 50% of the workbook. You have measuring instrument questions too in the workbook. Okay. So when is it going to start schools? No idea. No idea. Anyone? No. No. Yes, started next month. Okay. This month, 20th. What about others? No. No idea. Okay. Okay. So now let's learn the properties of dimensions. But I mean, I don't have to teach any properties of dimensions. Why? Properties of dimensions is equal to the properties of units, right? Okay, we have nothing new to learn in properties of dimensions. Why? It's equal to the properties of units, right? Why? I mean, you can't add 5 meters with 2 centimeters. What is the reason? These are different physical quantities, right? So basically you can't add different dimensions. Clear? Clear? So you can't add 5 meters with 2 kilograms. Why? 5 meters means dimension is L, length. 2 kilograms means the dimension is M. So you can't add values with different dimensions. Clear? You can't subtract values with different dimensions. Clear? So it's just the rule set which is related to units. Okay? There's nothing new. Okay? So you can't add or subtract different dimensions, but you can multiply and divide. Okay? You can multiply length by time, divide length by mass. Clear? So you can multiply or divide different dimensions, but you can't add or subtract different dimensions. Clear? Clear? Same rule set. And for a equation to be correct, okay, for an equation to be correct, you must have the same dimensions in both sides. Okay? That means P equals H rho G. This is pressure. What is the dimension of pressure? This one, right? We already got that. Clear? This is the dimension of pressure. M, L minus 1, T minus 2. H, height, dimension is L. Rho means density. Density means mass over volume. Mass, dimension of mass is capital M. Dimension of volume means L into L into L, right? Dimension of volume is length into length into length, right? Clear? H rho G. What is G? G is an acceleration. Clear? G is an acceleration. What is the dimension of acceleration? LT minus 2, right? We know that. Why? We know the unit, meters per second squared. It's length into T minus 2, time. Clear? So H means length, height. Rho means mass over volume. Volume is L cube. Clear? Then G means L T minus 2. Clear? So then you get M L minus 1 T minus 2. See? It's same. Clear? M L minus 1 T minus 2. Clear? It's same here. Clear? Got the idea? So for an equation to be correct, you must have the same dimensions in both sides. Clear? And again, a power can't have dimensions. Why? 5 to the power 2 kilograms is useless. Then 5 to the power any mass is useless, right? So you can't have dimensions here. Just the same rule set as units. Clear? You can't put anything with a dimension into a log function. Clear? You can't put anything with a dimension into a log function. Clear? Why? Log, then you can't have a length here. You can't have a mass here. You can't have a time here. All you can have is just a number. Clear? All you can have is just a number. Clear? So whatever you put into a log function, it must be unit dimensionless. Clear? Then again, as a result of a log function, you are not going to get any dimensions. Clear? So the value you are going to get out of this is just a number, just a numerical value, not a unit. Clear? Just as in units. Okay? Okay. So this result you are going to get out of this must be dimensionless. Clear? Then sine, cos, tan must be dimensionless. Why? Sine something means length divided by length, right? I mean, it's A over B. Sine theta means A over B, right? Sine theta means A over B. But A is a length, B is a length, then there's no resultant dimension, right? Clear? So whatever all the trigonometric quantities, sine, cos, tan must be dimensionless. Clear? Sine, cos, tan must be dimensionless. So the rule set, it's the same rule set as units. Okay? Clear? There's nothing new there. Try exercise 3. Try exercise 3 in your notebook. Question in your not the workbook, sorry. In your theory tute. Okay? Theory tute, units and dimensions theory tute. Exercise 3, question number 7, question number 8, question number 9, then 11 and 12. Try these questions. You will, I think heat, just know this one, heat is an energy, okay? Heat is an energy. You will need that for question number 8. Heat is an energy. Okay? Heat is an energy. Try question number 7, 8, 9, 11, 12. So for all these questions, you have to derive, okay? That's why I'm not giving you a table or anything like that. I think you have that table in your workbook, but just don't refer to that. I don't need you to get dimensions of energy directly from any table. I need you to use the concepts you know from all levels. Okay? You know several equations for energy. Use something like that, then create dimensions. Okay? I don't need you to take dimensions of anything from a table. Okay? Derive these things using the O-level knowledge. Try to derive these things using O-level knowledge. So hope you have the normal tute, right, everyone? For online students, if you need the normal tute, just inform. And for online students, especially YouTube live students, if you need any assistance, if you need to join the group, you need Zoom link, or if you need to get tutes, contact this number, 070 402 070 402 9701. 070 402 9701. And I mean, I don't need you to, uh, restrict these resources, okay? Whatever the papers we give, whatever the workbooks we give, share it with other students, okay, who are going to other classes. Then take their notes also, refer to those notes, okay? I'm not telling that my physics is best physics, there's nothing like that. So just refer to other notes. Look, other workbooks, other notebooks, just try those questions, okay? So like have an agreement with some of your friends that you take my note, you mark all the difficult questions. This is not required in units and dimensions, okay? These things will be required when we are learning actual physics, okay? So so just mark all the difficult questions in my tute, and there will be, I mean, you may have a friend who's going to another class, mark all the difficult, ask he or she to mark all the questions from difficult questions from their note, then exchange, okay? Then exchange. So just try to learn from everyone. That's all. Okay, you need the normal tute again. I'll again provide it in the Zoom chat. Okay. So question number 7, 8, 9, 11, and 12. Let's start with question number 7. I'll discuss question number 7. It's V over T, V over T equals pi over 8, pi over 8, a to the power 4, P. So here, uh, V over T, dimensions of V over T equals dimensions of pi over 8, a to the power P over KL. Dimensions of both sides must be equal. Clear? Dimensions here must be equal to the dimensions here. Then, how many steps you are going to write depends on, for now, even weekly papers, we are going with MCQs for several weeks. But then we are going to start with essay questions, short answer questions, different types of questions. Okay. Then after that, after like maybe 2 months, let's start a term test paper discussion. Most probably I'll divide students between schools and discuss separately the school term test papers. So that's why we need to know when your term test is going to happen. Why? Getting your term test quickly as soon as possible is really important. That's when the students start learning actually after the first term test results. Okay, that for many students that's when the A level starts. Since then it's just O levels. Okay, you use the same methods you used in O levels. You assume that you can manage everything at the last moment. Okay, you just freely walk around with the content. Then first term test, after first term test results, then you understand, okay, this is A level, so I have to do a bit more. That's the usual pattern in A level. So getting the first term test as soon as possible is really important. Okay, so V over T, dimensions of V over T equals dimensions of pi over 8, a to the power 4, P over KL. Clear? So, attention. There are steps, certain steps that you have to write in any question. Okay, even in a question like this, a very simple question like this, let's try to write the proper steps. But how many steps that you are going to write entirely depends on the moment. That means how much time you have left in the paper. How many marks allocated to the question. See, so that's why we write papers, we start writing papers. Even the number of steps that we are going to write for a question depends on the situation. Okay, how much time left there? Okay, how much time left there? Then how many marks are allocated for that question? Clear? So if we have plenty of time, it's better to write the proper steps. So proper steps means you can't directly write dimensions now. You should break it into parts. This is the proper step. If you have time, if you don't have time, you are going to directly write everything. But if you have time in the paper left, if you have time left, then you have to break this into parts before writing dimensions of each part. A to the power 4 means dimensions of A to the power 4. Here, P. Here, dimensions of K. Here, dimensions of L. Clear? You break it into parts. Then this is V. What is V? Volume. V is volume. Volume means L cube, right? Volume means length multiplied by length multiplied by length, right? So L cube. This is T, I think, right? Time, right? So capital T. Pi over 8. Pi over 8 is a dimensionless thing, right? It's just a numerical value. So this part, it doesn't have any unit. So it doesn't have any dimension. Clear? So it's dimensionless. Clear? A means radius, I think, right? A is radius. Radius means again a length. Radius means again a length to the power 4. Radius means a length. Length to the power 4. Clear? Then this is P means pressure, right? Yeah. I think we know the dimensions of pressure, right? Do we have? Let's try to use the memory, which I don't have. L to the power 4, P means L No, I mean, I can't remember stuff. M L minus 1 T minus 2, right? Yes. M L minus 1 T minus 2. ML. I mean that's one of the main reasons that I'm good at physics. I mean, I can't remember anything usually. I mean, I can't even remember my phone number or anything like that. So I mean, I write that coordinator's number every day, right? I should have remembered that. No, I don't have a memory like that. So even in A levels, I learned to prove everything. I learned to prove every equation. So in A level paper, I start by proving all the equations. Why I can't remember the equation? So I just start proving all the equations. So I have the proof of all the equations. So now I have all the equations with me. Whenever there's a question arise, I prove the equation and quickly use the equation. That's how I used to do A levels. So it takes a lot of time, but I mean it's fun. Okay. So unit of pressure M L minus 1 T minus 2. Clear? M L minus 1 T minus 2. Then K K. Here you have K. That's what we are gonna find, right? K. Again, this is length, right? A length, right? Yeah, it's length. L is length. That means again capital L. Ah, now you cross multiply and get K. Dimensions of K. So K equals, and this is an equation that you are gonna work in properties of matter. Yeah, the lesson properties of matter. This is Poisson's equation, as I remember. So K equals L to the power 4 M L minus 1, here T minus 2. Then I take this T here. Then I'm going to take K here. I have L here. Then L cube here again. See? I cross multiply and take K here. Clear? Clear? Okay. Now what? Now, see how I'm going to solve this. I mean, not a big deal, but this kind of discipline, if you can like follow, it's nice whenever you are doing any calculation. So this is L cube. I cancel out this one with this one. See? Why? It's to the power 4. Now it's L only, right? L to the power 4 divided by L cube, it's L. See? Now this L minus 1 and this L, I can cancel out, right? Or this L and this L. So I cancel out this one with this one. Clear? Then this T, this T, this T, and I'll cancel out minus 1. See? See? Why? T minus 2 multiplied by T, it's T minus 1. Then I have M, L minus 1, T minus 1, T minus 1. Clear? So why is it important to do like this? I explained last week, right? Sometimes you are doing the calculations for 2 pages, 2 CR pages, you are doing calculations, then you get the answer that it is not the required answer. Okay? You solve for everything, then you get the answer as the velocity of the person as 10,000 meters per second. Then you know something has happened. Okay? Now you have to backtrack. Okay? Check where did you get it wrong. So when you reach here, now you know. Okay? I have cancelled out this one with this one. Then I can check whether it's correct. This one with this one. I can check whether it's correct. Then when I'm checking, then all of a sudden I see this cell is simple L, this cell is capital L. By mistake, I have cancelled out these two. It's not happening here. Okay. Here it's capital N, here it's capital L. But assume the equation is like this. L to the power 4 M L minus 1. Don't think that they are dimensions. Think that they are different symbols for different stuff in a question. Okay, this is the mass of a person. This is the length of the leg. Okay, things like that. Okay, L to the power 4 M L minus 1 T minus 2. This is the time taken for the person to click the stopwatch. This is the time taken for the person to start running. You have different physical quantities like this, and all of a sudden you have simple L here. It's maybe length of the track. Then you have L cube here. But mistakenly, you cancel out this one with this one and this one with this one. Why? You are in a hurry, okay? I mean, in mechanics, I mean, for a maybe 2 3 pages question, you have only 20 minutes to finish the question, okay? You don't get hours to finish a question in A levels, okay? So you are doing all the calculations quickly. Now you are, when you backtrack everything. Now when you reach here, you know, see, that's why I cancel out this one in the same direction and this one in the same direction. Then I know that I cancelled out this one with this one. See, this one with this one. Why? It's in same direction. See, now when I'm checking this point, I find the error. This is capital and this is simple L. Then I find the mistake, then I can correct. Okay. So otherwise, if you just time in cancel out things in whatever the way you like, okay, then you have no idea. Okay. I mean, if you like, you can do the calculations like this, right? You know this is L to the power 4, you think that this is L to the power 4, okay, and this is L to the power minus 1, you just cancel out this one and this one, this one, this one. That's how you usually do, right? Okay, then you have no idea when you reach here, oh my god, okay, you have no idea how to find the error, right? See, now even you can't remember that you cancelled out this one with this one. See, now you can't recheck, okay, it's impossible. You are done with the question, you have to start a new question, okay? See, that's why doing calculations in a very neatly is really important. Clear? Ah, see, now you have the answer. Clear? Okay, next one. Question number 8. Question number 8. Write this down, then I'll move to question number 8. Others finish question number 9, 10, 11, 12, then mechanics tute. If you haven't finished the mechanics tute, try the mechanics tute. I know I always ask you to try the mechanics tute, and there are many questions that you were not able to do, right? So just try to finish that, okay? Finish that means, I mean, I just try, just try. Even take another question that you were not able to finish, try the same question, okay? And even for other classes, okay? If you are going for a lot of math classes, just take these tutes, okay? Why? You have a lot of free time there, right? I mean, the lot of teachers start telling stories, which I mean, which doesn't matter, okay? And I mean, for me, I don't have stories to tell, okay? I mean, I mean, I don't have a very bad past, which I struggled, then improved. No, I don't have a story like that. I was class first from grade 1. So no bad stories. Okay, it was very good from beginning, okay? So no stories to tell about my life. So you won't hear any stories here. Okay. So just take these tutes whenever you are going to other classes. Then when the sir starts telling stories, take the tute and try to finish that, okay? Anyways, the stories are useless. Question, okay. AC issues. Yep. Question number 8. H equals Ka, theta 1 minus theta 2 over L. H is the rate of flow of heat. Okay, we have to understand terms like this. Rate of flow of heat. So let's try this question. H is rate of flow of heat. That means energy over time. It's energy over time. Rate of something means divided by time, right? Okay. Rate of something means something divided by time, right? That's how we get the rate of something. Clear? So this is H is rate of flow of heat. That means it's heat is an energy. Heat is an energy. So it's energy over time. Clear? H is energy over time. Clear? Equals Ka theta 1 minus theta 2 over L. And you need to find dimensions of K. So energy over time, dimensions of energy over dimensions over time, then K, A, then theta 1 minus theta 2, then L, then L. Okay. So it's energy over time, Ka, theta 1 minus theta 2 over L. Energy. How can you get energy? I mean, whatever the energy, it's the same dimension. So you don't have to know anything about heat. You know kinetic energy, you know potential energy, you know work is energy. So you have many other ways to find the dimensions of energy, right? Yes, this is heat. But heat energy and kinetic energy is not two separate stuff, okay? It's the energy, right? So to find dimensions of energy, you can use something that you already know. Maybe half mv squared, kinetic energy. Clear? You can find dimensions of energy using kinetic energy, right? So half, there's no dimension. M means mass. M means mass, capital M. V means velocity. Velocity means LT minus 1, right? Velocity means LT minus 1, right? Half, there's no dimension, M, capital M. Velocity means LT minus 1, right? Then you get M L squared. L squared T minus 2. Clear? M L squared T minus 1 squared, that means minus 2. Clear? So dimensions of energy, M L squared T minus 2. Then this is time. Time. Time means capital T, right? Dimension of time is capital T. Equals, I need to find dimensions of K, I think. So let's keep it like this. This is A, area. Area means L squared. Area means L squared, right? Length into length, area. Theta 1 minus theta 2, they are asking us to take dimensions of temperature as theta. See, the main dimensions that we use in our syllabus is M, L, and T. If there's something else, I mean, can you write temperature using M, L, and T? Can you write temperature using M, L, and T? Can you write? Can you? Why? What is the reason? Nice. Why? It's a fundamental physical quantity. Temperature is a fundamental physical quantity. Can you remember? Fundamental physical quantities can't be written using others, right? Okay, they are original stuff. Clear? So you can't write theta, fundamental physical quantity, temperature using other stuff. Clear? So theta can't be written using M, L, and T. So you need another symbol for theta definitely. Temperature is a fundamental physical quantity. Clear? To write a fundamental physical quantity, you need other you can't use other dimensions. You can have to introduce something new. So they are asking us to take dimension of temperature as theta. So theta 1 is measured in theta, theta 2 measured in theta. It's theta. So theta minus theta, you get theta, right? Why? Temperature minus temperature, you get some kind of a temperature, right? So the dimension of this whole part is theta. Clear? Temperature minus temperature, you again get the temperature, right? Clear? Ah. So it's theta. Then this is length, right? This is length. That means capital L. Clear? This is again an equation that you are going to work with. This is the equation of conductance. How fast heat travels through something. This is the equation for conductance. Clear? These are the equations that you are going to work with in the future. Okay? So, see, these equations are huge. So, m L squared t minus 2, then you have t, k, you have to find k. L squared, theta minus theta, again theta, you are going to get the same dimension, then L. Clear? Ah. Then K equals ml squared t minus 2. Then you are going to take L here. ml squared t minus 2. Then you are going to take L here. Then you have t L squared. You are going to take L squared here. Then theta here. Clear? Clear? And although I write these things like this, I prefer if you are not using this cross for multiplication, okay? You can write a multiplication using this, right? 5 into 3 into t over r. You can write multiplications like this, right? I prefer if you can write like this. Why? I mean, the usual symbol that we use for a variable in physics is x, right? Clear? So when you're in a hurry, you can't, I mean, you have x and multiplication at the same equation. Okay, there are thousands of physical quantities in one equation. You have both x and cross here. You can figure out, I mean, the difference, okay, at some point, then it's a huge trouble, okay? So just don't use this symbol for multiplication. Just use brackets like this, okay? I mean, these days, let's improve the neatness of our answers so that we can make sure that when we start mechanics, we have that discipline in our answers, okay? So then L squared cancels out. T minus 2. So I can write here I have m. Then t minus 2, I take this one here. Then t minus 3. T minus 2, I take this one here. Another t minus 1. Then t minus 3. L here theta minus 1. Clear? Clear? Try question number 9, 11, and 12. Question number 9, 11, and 12. If you are done with that, next after this point, I'm going to start some questions from mechanics tute. Then next, we are going to move to units and dimensions again. Can I have the mechanics tute? Let's discuss question number from mechanics tute. Let's discuss question number. Did we discuss question number 13? Yes or no? No. So let's discuss question number 13 and 16. Question number 13 and 16 from mechanics tube. Try these three questions. Question number 9, 11, and 12 from exercise 3. From exercise 3 of the theory note. Exercise 3, question number 9, 11, and 12. Then mechanics tute, question number 13 and 16. Okay, I'll provide the tute again. Some students are asking for the tute. Tute ටිකයි දාන්න කිය. Even my staff is asking me to increase the temperature. I don't know how people live with such high temperatures. I mean, you are really inefficient when the temperature is high. The most of your energy is used to get rid of the excess heat in your body. So your energy is not pumped to your brain function properly. So lower the temperature, the more efficient you work. ඒකත් අවුල් තමයි. So both mechanics tutes and units and dimensions tutes are available in the Zoom chat now. So question number 9, it's simple, right? Question number 9. N equals n naught e to the power minus lambda t. This is an equation that you get in the last lesson, matter and radiation. This is how fast what we call that radioactive material decay. This is the rate of decay of a radioactive material. So n equals n naught e minus lambda t. Here n and n naught represent the number of atoms. T represents time and e is a numerical value, dimensions of lambda. So you don't have to think about this part, right? Why? At the end of the day, this is a power. This is a power. So power can't have dimensions. Clear? Power can't have dimensions. T is time. T is time. Then lambda must be 1 over T, right? Lambda must be 1 over T, right? Clear? Then they cancels out and this part becomes unitless, right? So T is time, capital T. Then lambda must be 1 over T, right? So dimensions of lambda, it's 1 over T. That means T minus 1. Clear? Dimensions of lambda is T minus 1. Clear? Clear, everyone? Then question number 11. Question number 11. Y k1 sin k2 t. Here y and t represents displacement and time. Find the dimensions of k1 and k2. Y equals k1 sin k2 t. This is quite important. Why? Only in this question you get different answers for units questions and uh, dimensions questions. Understand this, okay? Properly try to understand this. Time. This is time. Let's break this into two questions. One, find units of K1 and K2. Two, find dimensions of K1 and K2. You get two different answers. Why? See, sine something. This is an angle, right? This is an angle. So if they ask for the units, what is the unit of this part? It's radians, right? Can you remember? This is an angle, right? You put an angle into sine, right? Clear? This is sine. Here, the unit must be radians, right? Why? Here you put some kind of angle. What is the unit of an angle? Radians. Clear? So, here unit of K2 multiplied by unit of time. Here time may be seconds. Seconds. Time is measured in seconds. Then you have unit of K2 here. Unit of an angle is radians. Clear? So unit of K2 is, here the unit of K2 is radians over seconds. That means unit of K2 is radians per second, right? Radians per second. Clear? Unit of K2 is radians per second. Clear? Is that clear, everyone? But dimensions and angle don't have dimensions. Can you remember? Can you remember the definition of that supplementary physical quantities? These supplementary physical quantities, can you remember how to measure theta in radians? Can you remember how to measure theta in radians? You take this distances, we learned this last week. You take this radius, theta radians equals S over R, right? S over R. Can you remember definition of radians? So when you measure something in radians, unit is radians. Clear? But what is the dimension? This is a length, L. This is again a length. So it's dimensionless. See? When you this angle is a special thing. Okay? Why? It's dimensionless, but it has a unit. That's why I said that we can separate these stuff from other physical quantities. That's why they are in a separate container called supplementary physical quantities. Clear? That's why they are in a separate box called supplementary physical quantities. Why? They don't fall into fundamental physical quantities. They don't fall into derived physical quantities. Why? Their behavior is different. They are dimensionless, but they have a unit. See? It's quite different from the things we learned, right? In all other cases, if you divide a length by a length, it's unitless, right? Meters divided by meters, it's unitless. Kilograms divided by kilograms, result is unitless. But only here, length divided by length, it's dimensionless, but it has a unit called radius. See, these supplementary physical quantities, it's a different story. Clear? Supplementary physical quantities, it's a different story. Clear? So, only in questions like these, you get different answers for units and dimensions. Clear? So here unit of K2 is radians per second, but dimension of K2, this is an angle. This is an angle. So an angle is unitless, right? An angle is unitless. Can you remember? Sorry, not unitless. It's radians. It's dimensionless. See? L and L cancels out. So an angle is dimensionless. Clear? So this part must be dimensionless. So here dimensions of K2 into dimensions of T it's equal to a dimensionless physical quantity. That means 1. Clear? Here dimensions of K2 into dimensions of T, the result is dimensionless. Clear? Clear? Then dimensions of K2 is 1 over dimensions of T. This is time. That means 1 over T. That means T minus 1. Clear? So dimensions of K2 is T minus 1. But unit of K2 is radians per second. See, the story is little bit different there. When you have supplementary physical quantities involved, otherwise in all other cases you get the same answer for units and dimensions. Okay? If you get the dimensions as M, unit will be kilograms. If you get the answer as L, the unit is meters. It's like that, right? In all other questions, you get the same answer for dimensions and units. But when supplementary physical quantities are involved, clear? When supplementary physical quantities are involved, here it's T minus 1. But here it's not S minus 1, it's radians per second. Clear? It's a little bit different here. Okay? You have to be careful about this kind of stuff. Then again, this whole part don't have a unit. Okay? This whole part, it's unitless and dimensionless. Result of a sine is unitless and dimensionless. Why? It's L divided by L. Clear? Result of sine costan is dimensionless. Then definitely dimensions of y is equal to dimensions of k1, right? Why? This part is dimensionless. Then dimensions of k1 is equal to the dimensions of y. Then y is A represents displacement, right? No, that's not the question. Question number 11, right? Yeah. Y is displacement. Y is displacement. Displacement means length. Then dimensions of K1 is length. Clear? Dimensions of K1 is length. Is that clear, everyone? Try to analyze this properly, and especially online students, please mention if you need me to discuss this question again. I'll give you the interval now. And you can try mechanics question number, what are the numbers? 13 and 16, right? Oh, yes. You can try question number 12, exercise here, exercise 3, exercise 3, question number 12. Then mechanics tute, question number 13 and 16. And if you're done with these questions, just try other questions. I'll give you the interval. It's 5:15. I'll start around 5:35. I'll start around 5:35. Try exercise 3, question number 13. Then mechanics tube 13 and 16. Just inform if you can't find the tubes. And if you can't, if you need any other information, contact this number. Not 70402, not 70402 9701. And if you need me to discuss this again, inform. Sure, there are requests to explain this again, okay? So the first thing I'll do after the interval is explaining this question, okay? So the first thing that I'm going to do after the interval is explaining this question. Try these questions, okay? Try these questions. Exercise 3, question number 13, then mechanics, question number 13 and 16. And if you are done with these questions, try other questions. Maybe mechanics two, question number 14, 15, 16. Try other questions. And while you try these questions, I'll explain this answer for this question again. I'll explain this a bit. Uh, so this one, it's y equals k1 sine k2t. So I divided this into two questions. One is, what is the unit of k2? And next question is, what is the dimension of k2? These are two separate questions and the answer is different. Why? Sine, you always put an angle into sine function, right? Sine is a function. And here what you have is an angle, right? Clear? So, what is the unit of an angle? What is the unit of an angle? Radians, right? Unit of an angle is radians. So, unit of this part must be radians. It's equal to unit of k2 into unit of time. Time means seconds. Time means seconds. Then what is unit of k2? Radians. You take seconds here, then you get radians per second. Unit of k2 is radians per second. Radians per second. But if we ask the dimensions of k2, the story is a little bit different. Why? I mean, you need the knowledge from last week's sessions for this, okay? So if there's anyone who haven't watched last week's sessions, I'll provide all the recordings today in the group. So this is an angle. SI unit of measuring angles is radians. Then the definition of radians is, actually the definition of an angle is, this is how they define radians. If you need this angle theta, you can take theta using S, this circumference, this part of this circumference over radius, S over R. Using S over R, you can take the angle. That's how the official SI unit system has defined theta. Clear? So that's how the official SI system has defined theta. S over R. Clear? We explained this last week and we did some questions from this one too. Clear? Can you remember? So now if you try to take the dimensions of theta, it's S over R. S means a length. R is a length. So length divided by length, it's dimensionless. Clear? So theta angle, it unit of theta angle is radians, but dimension of theta angle is, it's dimensionless. Clear? So if you need to find the dimensions of this part, it's dimensionless. That means dimension of k2 multiplied by dimension of t, it's dimensionless. Clear? Then k2, dimensions of k2 equals 1 over dimension of t. T is time, dimensions of time is capital T. So dimension of k2 is t minus 1. Clear? So the unit of k2 is radians per second. Dimension of k2 is t minus 1. Clear? Now the next question, they ask the dimensions of k1. It's not that difficult. Why? Result of a sine function is dimensionless again, right? Result of a sine function is dimensionless. Sine something is dimensionless. Why? Sine something means length divided by length, right? So sine something is dimensionless. Then dimension of y is equal to dimension of k1. Dimension of y is length. Then dimension of k2 is length. Is that clear? Clear? Ask if you have any questions. Try these questions. Try to finish these questions. If you are done with these questions, try other questions. Got the idea, students who asked this question? Students who asked me to explain this again, please mention whether you understood that or not. Okay. So, and someone asked about the how are we going to discuss the model paper. I'm still planning that. I mean, I can provide you an answer script, or else I can provide you a small recording. It's just 10 questions, so I can provide you a recording of the answers. I mean, the explanation. Or we can maybe discuss this after the class if required, but then the length of the class will be too much for you guys. Or else we can have a separate online session. Maybe 1 hour will be enough for the whole to provide the whole answer script to explain everything. Maybe 1 hour session, maybe in another day. So I think the recording will be okay, right, for this one, since it is a very small paper for now. I think then let's do it this way. I'll provide you a recording and okay, let's do it this way. For the model paper, every week I'll provide you a small recording and an answer script. Okay, so the recording will be most probably 1 hour. So if you need to check only the answers that you got wrong, check those questions, okay, from the answer script. Okay, first you have the discussion and the answer script. You first check the answer script. Then you try check the questions that you got wrong using the answer script and you try to understand them. And there will be 1 or 2 questions that you can't still understand. Then for those questions, go and watch the recording. Then it's just a 20-minute task, right? It's just a 20-minute task. Okay, if you have 6, 7 questions wrong, okay, for like 3, 4 questions you will understand just by looking at the answer script, right? There will be a small explanation in the answer script. Then there will be 3, 2 questions remaining which you can't understand just by looking at the answer script. Then watch the recording for those 3 questions, okay? Then it will be really convenient, okay? I mean, whatever we do, we have to find the best time efficient method, okay? That's the basic idea. Whatever we do in A levels, we should try to find the best time efficient method, okay? I mean, if you have time left, okay? If I mean, if there's a person to do something, if a person takes 4 hours, if you can take it, do finish it in 2 hours and sleep for 2 hours, then it's good, right? So that's the idea, okay? So whatever you do, try to do it in using a minimum possible time, okay? Focus on efficiency always. Okay. So here question number 12, right? Question number 12, exercise 13, question number 12. Exercise 13, sorry, exercise 3, right? Did I say 13? Yeah, I have written 13 everywhere, right? It's 3, sorry. There's no exercise 3 in the exercise 13 in the theory tute. Sorry, it's exercise 3. Exercise 3, question number 13. Okay, no big issue there. Exercise 3, it's exercise 3, question number, not 12, 13, right? I asked you to try 13, right? Not 12. Okay. Or did I ask you to try 12 and 13 both? 12. Okay, then let's discuss both after the mechanics question. I'll give you some time to try question number 12 and 13. I'll discuss the mechanics questions. I'll discuss mechanics tute. Then I'll discuss question number 12, 13 both. Let's do it that way. So the mechanics tute. Mali. Mechanics tute. It took a man 60 seconds to climb an escalator that was not in use. When he is stationary in the running escalator, it takes him 30 seconds to reach the top floor if he travels up the running escalator. If travels up, okay. Okay, the question is not that, I mean, clear, right? So what they mention is, I mean, there's a small, I mean, the question is not that clear. That is the problem, I think. So what they mention is something like this, okay? Uh, if he travels up running, that is the basic. It's not the. If he travels up running, I think when he is stationed in the running escalator, it takes 30 seconds. Ah, no. Okay, okay. The question is correct. It takes 60 seconds to climb an escalator. Then when he is stationary, when the escalator is moving, it takes 30 seconds. Then now if he's running in the moving escalator, what is the time taken? That means the question is like this. Hope all the online students have the mechanics tute. Just inform if you can't find the mechanics tute. Okay. So question number 13 of the mechanics tute. There's a certain length here. Okay. There's a certain length. Initially, when he is stationed, it took a man 60 seconds to climb an escalator that was not in use. Now the escalator is not moving, but the person is running. So if we take the velocity of the person as v1, if the velocity of the person is v1, time taken for this person to move from here to here is 60 seconds, right? Time is 60 seconds. Time taken is 60 seconds. So now it's like this. What is the definition of velocity? Definition of velocity s over t, right? Definition of velocity s over t. Clear? Then I can write v1 is the velocity of the person. L is the distance from this floor to next floor. Time taken for this process is 60 seconds. Is that clear? 60 seconds. Clear? So length is L. Velocity of the person is 60. Velocity of the person is 60. So it's V1 equals L over 60. Is that clear? V1 equals length is L, time is 60. Clear? Now the person is not moving. The person is not moving, but escalator is moving. So if we take the velocity of the escalator as V2, now the person is not moving. Clear? But the escalator is moving. As a result, the person is moving up. It takes 30 seconds, right? It takes 30 seconds. Clear? So the velocity of the escalator is L, length is L, over time is 30. Clear? Now, he is running and escalator is moving. So, what is the resultant velocity? It's V1 plus V2, right? Escalator is moving and the person is running. So what is the combined velocity? V1 plus V2, right? Why? The person moves up with his velocity plus the velocity of the escalator, right? Clear? When you are running in a moving escalator, you can move faster, right? Why? Your resultant velocity is your velocity plus the velocity of the escalator, right? That's why you can run in an escalator and move faster, right? Clear? So the combined velocity is v1 plus v2. Clear? And time taken is capital T. Clear? Time taken for this process is capital T. Clear? Clear? Now what? So I can write velocity, combined velocity v1 plus v2. Length is same. Length is same, L. Length is same, L. I need to find the time, right? Clear? I need to find the time. Length is L, it's same, right? Length is always same. Time is T, combined velocity v1 plus v2. So what can I do here is I can take T here, up, then v1 plus v2 here, L over v1 plus v2. Then what is the length? It's L. What is v1? L over 60. plus what is V2? L over 30. Then L cancels out. I get 1 over 60 plus 1 over 30. Clear? Then I get uh, common base 60. Here 61. Here 2. Clear? Common base I make it 60. Then it's 1 over 60, 2 over 60. Clear? I add these two. Then I get 1 over 3 over 60. That means 1 over 1 over 20. That means 20. Clear? The final answer is 20. So it takes 20 seconds for this person to move up. Clear? It takes 20 seconds for this person to move up. Clear? Any questions? Inform me if you need me to discuss this question again. Then question number 16, mechanics. Question number 16, next one. Okay, you need the mechanics tools again, right? Yeah, there's a question. But radian is something related to sectors and sine is something related to triangles. Yes, radians is defined using sectors. It's true. But that is the official SI unit of an angle. That is the official method of defining an angle according to SI conventions. Clear? So radians is the, although it's, I mean, you put an angle into sine function always, right? So in a sine function, what you have is an angle. An official definition of an angle is radians. So they are connected still. Clear? So you need the mechanics tute again. Well, so mechanics tutes will be available in the group again, in the Zoom chat again. And one main reason that I decided to do the question today is that now we have this online option, but whenever possible, please try to come to the physical class, okay? And from next week onwards, I mean, this is not important at this moment. It will be, I mean, you will find it important maybe after 2-3 weeks. From next week onwards, there will be around 3 or 4 invigilators after the class where you can ask questions after the class, okay? So for any subject, most probably there will be invigilators in the class after the class. So after class, you can directly ask questions from them, from every subject. And like you can, I mean, the people will be there most probably until 10 p.m., okay? So if you have questions, you can clarify all the doubts until 10 p.m., okay? So that is the idea. Now you don't have any doubts, I know, but there will be a time maybe within 2-3 months or maybe after first term test, then I mean then you find everything difficult. That's what usually happens from up to first term test. Okay, this is not that difficult. Okay, okay, I just have to use the equation. Then you get a lot of nice questions in the first term test. Then you find everything difficult after the first term test. That's what usually happens in A levels. Okay, so you will find it really useful most probably after first term test. That's what usually happens in A levels. So after both Sunday and Thursday class, there will be you can find our invigilating panel after the class. And for online students also, we will arrange something similar. There will be a Zoom link where you can join, and you will be divided into breakout rooms. So you can go into different breakout rooms and ask questions from our invigilators, okay? So there will be the same system, same method implemented for both online students and physical students, okay? So yeah, you can join a common Zoom link, but there will be breakout rooms. You can join a breakout room. You will be assigned into a breakout room, and there will be an invigilator in the breakout room, and he will, he or she will explain you whatever the questions that you have. Okay, so next question number 16. But for students who can join the classes physically, please do try to join classes physically. Question number 16. When two objects A and B move in the same direction along a straight line, B approaches A at a rate of 2 meters per second. When two objects A and B moves towards each other at the same speed, they approach each other at a rate of 4 meters per second. Find the speed of A and B. Okay, what is the speed of A and B? Uh, it's like this. This is per second. Everything is mentioned per second. That means what is the definition of velocity again? Definition of velocity is distance over time. Distance over time. Then distance means velocity into time, right? Distance or displacement is velocity into time, right? And per 1 second, what is the distance traveled by the person or the displacement traveled by the person? Per 1 second means time is 1, right? Time is 1. Clear? Time is 1. So, per 1 second, distance traveled is v. So, so the so for in 1 second, a person travels a distance equal to its velocity. Clear? Clear? So it's v into 1 per 1 second. This is the distance traveled per second. Clear? S equals v. Now when they are moving, both A and B move in the same direction along a straight line. Both A and B moves in a straight line, and B approaches A at a rate of 2. So we have B here, A here. Within a second, if the velocity of B is VB, if the velocity of A is VA, within a second, B travels a distance equal to VB. Clear? Why S equals V. Within a second, A travels a distance equal to VA. Clear? Then this difference is VB minus VA. So this is what they have given as 2 meters per second. Clear? That means per second their distance reduced by 2 meters. I mean, if I properly explain, if there's a person here, if there's another person here, if this person moves 3 meters, if this person moves 5 meters, their gap reduce by an amount of 2 meters, right? See, if this person moves 5 meters, if this person moves 3 meters, their gap is reduced by 2 meters, right? Clear? So if this person moves VA in 1 second, if this person moves VB in 1 second, the difference of their gap will be 2, right? Clear? Now when they are moving towards each other, that means VB is moving in this direction, A is moving in this direction, VA. So in 1 second, this person moves the distance of VB, this person moves the distance of VA, so their gap will be reduced by VA plus VB, right? Clear? Why? If there's a person here, if this person moves 2 meters, if this person moves 3 meters, altogether, their distance will be reduced by 2 plus 3, 5 meters, right? If a person moves 2 meters in this direction, if the other person moves 3 meters in this direction, their distance will go down by 2 plus 3, 5 meters, right? That means this value plus this value. So this person in a second, this person moves a distance equal to VB. In a second, this person moves a distance equal to VA. So their gap will go down by VA plus VB. Clear? And they have given that it is equal to 4 meters per second. Clear? So they have given that it's equal to 4. Clear? So you have two equations, VB minus VA equals to VB plus VA equals 4. VB plus VA equals 4. Clear? So to calculate, you add these two equations 1 and 2. You add these two equations 1 and 2. When you add VA minus VA, they cancels out. VB plus VB, 2VB. VA minus VA, they cancels out. VB plus VB, it's 2VB. Here 4 plus 2, it's 6. Then I get VB equals 3. VB equals 3. Clear? Then you put this value here maybe. 3 plus VB is 3 plus VA equals 4. VB is 3 plus VA equals 4. Then VA equals 1. 1 meters per second. Clear? Clear? Write this down. Anyone need me to repeat this question? Okay. So write this down, but I'll repeat this one. I mean, to give you a rough idea, if there's a vehicle moving with a velocity of 10 meters, 5 meters per second, and if there's another vehicle moving with 3 meters per second, their distance will go down by 2 meters per second every second, right? Why? In 1 second, this person moves 3 meters, this person moves 5 meters, okay? There's a person moving with a velocity of 3 meters per second. There's another person moving with a velocity of 5 meters per second. Clear? So this person will move 3 meters in a second. This person will move 5 meters in a second. So their distance will reduce by 2 meters per second, right? So the difference in their velocity, VB minus VA equals to 2. When they are moving towards each other, this person will move VB in this direction, this person will move VA in this direction towards each other. So their gap will be reduced by VA plus VB, right? Why? Both walks towards each other, right? Clear? So their gap will go down by VA plus VB. Clear? And it is equal to 4. That's what they have mentioned, right? So we have two equations, VB minus VA equals 2. VB plus VA equals 4, and I add these two equations, then I get VA to VA cancels out 2 VB equals 6, then VB equals 3. Then I take this value VB equals 3 and I put it here. Then 3 plus VA equals 4. I take this value and put it here in the equation. 3 plus VA equals 4, then VA is 1. Clear? Clear? Got the idea? Okay, then let's return again to units and dimensions questions. And as I mentioned, within like 2 or 3 weeks, no, most probably not next week, the week after that, we'll be able to start measuring instruments, okay? Then with the measuring instruments labs will start. So we'll divide you into teams and we'll let you do the practicals, okay? I have bought all the practical instruments this time. So we'll ask you to do the practicals here. So that you can try it. Why? This is, I mean, you are supposed to do these things at school, okay? But I mean, we always ask students to do these stuff at school, go to school and try to finish these stuff, but it never happens, okay? It at least happens in the first 1 or 2 uh, like terms, but after that students usually don't do the practical. So we'll try to do many practicals here, okay? The at least the practicals which you can't kill each other, not heat practicals. We have practicals like that. I mean, that's why, I mean, there's a huge issue. Like before there were practicals related to mercury in our syllabus. But now all the practicals in the new syllabus, all the practicals related to mercury has been removed. One main reason is, yes, mercury is expensive. It's really expensive. And the other thing is, I mean, when you ask students not to touch mercury, that's the first thing that they do, right? They took some mercury and put it to the shirt of the other guy. Okay. So that's what you usually do, right? That's what you usually do. That's the first thing that you're gonna do, right? Okay, if they ask you not to touch mercury, when the other person is doing the practical, you would take some mercury and put it into in the other person's hand, right? So that's what happens. So since it's like, it's not good, right? It's cancer leading. So all the practicals related to mercury was removed. That's how the practical syllabus was evolved. Okay. So next one. Okay. Any questions, online students? How did I get the VB part? VB is just the velocity of B. VB is the velocity of B. VA is the velocity of A. So in 1 second, the distance you travel is equal to V. S equals V. That's the idea. Clear? Clear? Okay, there are some requests. Definitely the last questions. There's a request to do 28, 11. Okay, last questions. I mean, every week we'll be doing 2 questions. So I'll most probably within like 1 month, I'll finish all the questions in the tute most probably. So you don't have to worry about that. So initially, for now, I'm just doing the initial questions, first 20 questions. So there's a request to do question number 11 from a lot of students. Let's try that and move to units and dimensions. Question number 11. A drunk person takes 5 steps forward and 3 steps backward. Each step is 1 meter long and takes 1 second. There is a pit 9 meters away from the starting point. Find the time it takes for him to fall into that pit. Okay. It's like this. Attention. Question number 11. Why a lot of students ask this question? There's a person, he takes 5 steps forward and 3 steps backward, each step 1 meter long. There's a pit 9 meters away, and time taken for one step is 1 second. Find the time it takes for him to fall to the pit. Okay, now the person is here and the pit is here. Gap is 9 meters. Gap is 9 meters. So one step means 1 meter. You have to move 9 meters there. So he keeps 1, 2, 3, 4, 5 steps forward, then 3 steps backward. 1, 2, 3. 3 steps backward. Clear? So each step takes 1 second and 1 meter. So 1 second, one. So it takes 1, 2, 3, 4, 5, 6, 7, 8. 8 seconds for him to move actually 2 meters, right? Why? It's 5 meters, but 3 steps backwards means 3 meters. Then it takes 8 seconds for him to move 2 meters. Clear? Okay. So it's 8 seconds per 2 meters. Clear? And he has to move 9 meters, right? 9 meters. So within the first 8 seconds, he moved 2 meters. Within the first 8 seconds, he moved 2 meters. Clear? Why it takes 8 seconds for this process? Clear? After that process, he takes 8 seconds and move 2 meters forward. Clear? Then within the next 8 seconds, he moved 2 more meters. Clear? Clear? Now it's altogether 4 meters. But after that, you can't do this. Why? After that, there are 5 steps. So this is 2 plus 2. Then within next 5 seconds, 1, 2, 3, 4, 5. He will complete 5 meters. Then the pit is here. See, the pit is here. I mean, he don't have, I mean, he can't return again, right? He can't return again. After these 5 meters, he's already in the pit. Why? It's 9 meters. Clear? Clear? Got the idea? I'll explain again. Is this clear? It takes 8 seconds to move 2 meters. Again, it takes 8 seconds to move next 2 meters. Now it's 4 meters. But you can't keep doing this. Why? Now it's 5 meters remaining. And next, before returning, he definitely moves 5 steps forward. So when he moves 5 steps forward now, before returning, he falls into the pit. So for this part, you can't use this resultant value. For this part, you can't use this resultant value. After these two, this is a resultant. This is a resultant. He moves 5, returns 3, moves 2 meters forward. But after that, he has 5 meters remaining. So within these 5 steps, he falls into the pit. So it takes 1 second, 2, 3, 4, 5. So for this process, per each step, he takes 1 second. So it's 5 seconds. So the total is 8 plus 8 plus 5. That means 21 seconds, right? 21 seconds. Clear? Clear? Doing these kind of questions, that's good that you asked that question. It's a nice question. Doing a lot of these kind of questions, I mean, when we move into mechanics, then you will be able to understand a lot of practical scenarios, how to use your knowledge in mechanics. Then doing mechanics will be really easy. Got the idea, everyone? Clear? Clear? And there are requests to do 27, 28. I'll discuss those questions definitely in the future. Okay. Then again, back to dimensions question number 12 and 13 of exercise 3. Write this down. Then exercise 3, question number 12 and 13 I'll discuss. Okay. So, well, it's L equals C log K over L, right? No, it's I, right? Sorry. Yeah, it's I equals exercise 3. I equals C log K over L. And I repeat, if there are online students who didn't fill that form for tube delivery, please fill that form because we are going to finalize everything and we will start delivering tubes from most probably within 2 days. We'll start tube delivery. So I equals C log K over L. C log K over L. L represents displacement. L represents displacement. What is the dimension of displacement? Capital L. Dimension of displacement is capital L. Then uh, C represents velocity. C represents velocity. That means meters per second. That means LT minus 1. LT minus 1. LT minus 1. This is L. This is LT minus 1. Then you can't put anything with a dimension into a log function. Clear? You can't put anything with a dimension into a log function. So if this is L, this must be L, right? Then L to L cancels out. Clear? If this is a length, if this is a length, this must be a length, right? Then length to length cancels out. Clear? Clear? Ah. So the dimension of K is L. Dimension of K is L. Clear? Then C equals L. And again we know that result of a log function don't have units, right? Result of a log function don't have units and don't have dimensions, right? So this one won't give you any dimensions, right? Log something is just a number, right? Okay. So this is dimensionless. Then dimension of C is LT minus 1. Then the dimension of the whole part is, this part is dimensionless. This is LT minus 1. Then the resultant will be LT minus 1, right? Why? You multiply something dimensionless with LT minus 1, right? You multiply something dimensionless with LT minus 1. Then you get LT minus 1 out of it. Clear? So this side is LT minus 1. Then this side must be LT minus 1. If dimensions are not equal, you can't write this equation. So if this is LT minus 1, then this is LT minus 1. Clear? If this is LT minus 1, this is definitely LT minus 1. Clear? Clear? Next. Question number 13. Question number 13. Write this down. And if there are students who can't write the paper before the class, you can write the paper after the class. And at the same time, the usual time slot will be from 1:45 to 2:45 or 2 to 3, something like that. Okay. And I got the mark list too, but I mean, I usually read top 20 marks. But let's start it from next week onwards, because today it was not well planned and all, but from next week onwards, everyone knows how things happens. So online students, you can start exactly on time and finish exactly on time. The forms will be closed exactly on time. We'll start at 1:45 and finish at 2:45. That is the plan. And for physical class students, same plan goes. And yes, school starts quickly. Then let's discuss. We can shift the class a bit. Then do the paper before the class, or else we can shift the paper after the class. Okay, we have both options. Let's discuss when school starts. And whenever the school starts for other students, we can do go with the same plan. Okay, so whoever has schools, there are some schools starting maybe next week, the week after that, they can write the paper after the class. Okay, I mean, it's just flexible. Okay, you can do whatever you like, but make sure that you are writing the paper within 1 hour, and we are trying to make sure that 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 is guaranteed. Okay, so that's the plan for now. And we are planning like whether we are giving two different papers for Sunday class and Wednesday class, or what to do. Because if the paper goes in the group, then after that giving the paper in the Wednesday class or Sunday class again is pointless. Okay, because you have the paper available in the group. So we may move it into the website, our website, and everyone set up the website. I'll provide the details on how to set up the website. For now, you can join through the open Zoom links available in the WhatsApp group. And we'll see what to do after that. If it is the same paper, we'll provide it through the website. You can take it from the website and write. But if possible, I try to make two papers for Wednesday class and Sunday class, so similar papers, but different questions. Okay. Then if you like, you can do both papers. All the papers will be available. Okay. I'm still working on it. Okay. I'm still working on it, but every week you will have a paper before the class. And if you can't write the paper before the class, you can write it after the class. Okay. And anyways, if you can't, and it's not mandatory, if you like, you can write the paper. If you don't like, you can skip the paper and you can take it home and you can write it whenever you like. Okay. So it's not mandatory. Okay. But I prefer if you can write so that you get used to an exam environment at least a bit from beginning. Okay. So, and even today we didn't restricted anyone. Okay, we just let you talk and discuss and do the paper. So like within like 1 or 2 weeks, we'll make it proper. Okay, and it's open book. Okay, you can refer to your books. Okay, the duty is open book. Okay, so just refer to your books. Okay, we don't care. Okay, anyways, after 2-3 weeks, you can't get anything out of your books. Okay, anyways, it's physics, so whatever you have in your books is useless. You have to apply the knowledge you have in the questions. Okay, so whatever you have in your books will be useless after 2-3 weeks. Okay, when we start, especially when we start mechanics. Okay, so let's like try to regulate everything and make it proper. Then let's continue it. Okay, still I'm working on it, how to make this a proper exam at least. Okay, so next question number 13. Y equals a sine theta x. Y equals a sine theta x. A represents displacement. Find dimensions of theta x and y. Okay. Now this is the idea. X is a power. A power is dimensionless. Power is dimensionless. And this is little bit different. Attention everyone. This question is little bit different. Theta is dimensionless. It's just a number. 3, 4, 5. Then what should be the unit or dimension of theta? It should be dimensionless, right? Why? Okay, it's not that difficult. It should be dimensionless. Why? If you have a dimension here, if it is length to the power x has a dimension. If it is mass to the power x has a certain dimension. But can you remember, here this is an angle. Angles don't have dimensions. Can you remember? By definition of radians, can you remember? By definition of radians, angles can't have dimensions. Okay. If you don't understand this, remember this. Okay, that's all. Clear? What? angles can't have dimensions. Okay, why? In proper SI format, angle is defined like this. Angle is defined. What is this angle? Theta. It's the value that you get when you divide this S by this R. That's how in official, we learned this last week. That's how in official SI system, that's how they have defined an angle. Whatever you knew up to this point about angles, just forget that. This is how they have defined angle in SI unit system. Clear? You take this length covered by this angle, you divide it by the radius of the circle. Clear? According to this definition, an angle can't have dimensions. Why? S is a length, R is a length. So it's length divided by length. So according to, I mean, up to this point, you may know different stuff, but since now we work in SI system, angles can't have dimensions. Clear? And definitely into a sine function, what you put is an angle, right? You have to put an angle here, right? You never try to find sine of 5 kilograms, right? You need sine of 30 degrees, sine of 50 degrees, sine of 40 degrees. You try to find sine values of angles, right? Clear? So theta x must be an angle. Clear? So this is an angle. Angles are dimensionless. Angles must be dimensionless. So theta must be dimensionless. Why? Something dimensionless to the power something, it's still dimensionless. So theta must be dimensionless. Then to the power x will be again dimensionless. Clear? So theta is dimensionless, x is dimensionless. Why? X is a power. Power can't have dimensions. Clear? So power is dimensionless. Theta must be dimensionless. Why? Theta is an angle. I mean, here you must have an angle. Angles are dimensionless. Clear? Angles are dimensionless. So theta must be dimensionless. Clear? Then uh, A means displacement and result of a sine function, again dimensionless, right? Result of a sine function, again dimensionless. So this part, it's dimensionless. So dimension of y is equal to the dimension of A. A is displacement. That means A is length. A is length. Then dimensions of y equals L into nothing. That means L. So dimensions of y is L. Clear? Dimensions of y is L. Clear? This is the idea. At what time do we finish the class? Now? Okay, 6:30. So I mean, it's not 6:30 yet. It's 35. Okay, anyways. So I mean, I don't have time to finish I mean, the dimensional analysis. So next week, let's do dimensional analysis. Try some questions from the tute. Okay. And no, you can't add or subtract different units. You can't add or subtract different dimensions. I'm answering a question mentioned in the Zoom chat. You can't add or subtract things with different dimensions or things with different units. Yeah. So that's all for today. Try some mechanics questions, try some questions from the tutes. That's all. Just look in to the tute and read stuff and come when you come in the next week. Okay, and try to come to the physical class. I know today I mentioned that it's good if you can join online if you have transport issues or anything like that. But I mean, whenever possible, try to come to the physical class. Thank you.